In this lesson and the next lesson, we're going to look at Hooke's law. So Hooke's law relates the extension of a spring or a wire to the force that's applied to it. So in this situation here, we've got a spring, and at the moment the spring's relaxed. That's to say, it's at what we call its normal length. So at this instant, no force or load has been applied to the spring. So what we're going to do is we're going to apply a load to the spring, and we're going to measure how the extension changes. So we apply a force by attaching a weight to the spring. The force is equal to m times g, and as you know, Newton's law states that if you apply a force in this direction, pulling downwards, then the support will pull back on the spring in the opposite direction. Okay, so what we're doing then is we're going to measure the extension as we increase the weight that's attached to the spring. That's to say, we're seeing how the extension changes with the force applied. Now, it may seem a little bit odd in this situation because normally the controlled variable goes along the horizontal axis and the variable that you're measuring goes at the vertical axis. But when we draw graphs which demonstrate Hooke's law, the force always goes at the vertical axis and the extension along the horizontal axis, even though the force is the controlled variable in this particular case. So what we do is we add our weights and we measure the extension each time, and we plot the points on a graph, and let's say that the graph looks like this. First of all, what you observe is that there is a linear relationship. There is a relationship of proportionality. That's to say that for every given change in the force, an equal change in extension is produced. So Hooke's law states that the extension produced in a spring or by a wire when a given force is applied to it is proportional to that force. Okay, so we can say that the force is proportional to the extension in the spring or the wire. And what we'll do to get rid of the proportionality sign, we need to add a constant to this equation. So we'll do that. We'll say that the force produced by the spring is equal to the spring constant, k, multiplied by x, the extension. And this is the spring constant. So let's just put a box around that. That's known as Hooke's law. Okay, and in a typical question, you might be asked to calculate the spring constant for a given spring or a given wire, for example. So let's just do that for this one. Okay, and the spring constant is equal to the slope of this graph. That's to say, it's equal to the vertical change in the force divided by the corresponding horizontal change in the extension. Okay, so in this case, k for this particular spring is equal to F divided by x. So we can plot in, for example, a force of 3 newtons produces an extension of 15 centimeters. So that would be 3 newtons divided by 15 centimeters, which gives us a spring constant of 0.2 newtons per centimeter. So you might be asked to compare various springs, and as we've just stated, the spring constant is equal to the slope of the spring. So if we measured another spring, for example, which had a different slope, maybe a slope like that, immediately on observation you can see that the slope is steeper, therefore it must have a higher spring constant, and what that means is that it will be a stronger spring. In other words, the force required to produce an extension of 10 centimeters in this spring here, let's call that spring B, is equal to 6 newtons, whereas the force required to produce an extension of 10 centimeters in spring A is only 2 newtons. Okay, so this is the stronger spring. So typically in exam questions, you're often given a set of data which you have to plot, and you find out that the spring you're looking at obeys Hooke's law, and you may be asked, for example, to calculate the extension, for example, when a force of such and such is applied. So you might be asked, what is the extension produced in spring B? Okay, that's this spring here, when a force of 4 newtons is applied to that spring. So you'll have a nice sharp HB pencil, which you should take into the exam with you, and you should have a ruler too. And so you mark on the graph 4 newtons. You extend that across the graph, and then you draw a line vertically downwards from the intersect, and then you can estimate the extension that it would produce. So in this case it would be 6.7 centimeters, for example. Now, Hooke's law states that there is a linear relationship between the extension and the force applied to a spring or to a cable, but this law only applies if the extension or the force is within what is called the limit of proportionality, or the elastic limit. So if we go over that limit, then Hooke's law will no longer apply. So what we're going to do in the next lesson is look at the elastic limit, or limit of proportionality, for Hooke's law.